Hi everyone, welcome to this Cloud Next recap session, top 10 things at Cloud Next. So Google Cloud Next 2021 started on the 12th of October and we're going to wrap it up in this session and give our insight on some of the most notable and interesting changes to Google Cloud Platform. All of these features that we're going to cover today are available because Cloud Next was a virtual event. Are available now. You can go create a playlist. You can cover and have a deep dive on all of the services that we mentioned. You can go and watch the introduction talks and so a great way. And we'll put these links in the description for this video. A great way to go and sort of do your own exploration of that content is to go to the Cloud Next website and pick the services that are interesting to you and let us know if what your top 10 is. If you think we missed a service, it would be great to hear what you thought of or if you think we got the order wrong. If you think my number 3 should have been my number 1, let us know that too. So my name's Darren and I'm joined by Bernhard and Chris today, and I want to give you just a brief international to our host and the company that Bernie, Chris and I work for, DoiT International. So DoiT International is a cloud consultancy. We're actually for 2020, the last year we were awarded Google Partner Reseller of the Year. And we help customers in the digital native space and small and medium-sized businesses to optimize their deployments on Google Cloud. And the way we do that is with consulting and support by leveraging our cloud platform, a single pane of glass view over your cloud estate. And the best thing about coming and working with DoiT is that there's no cost to consolidating with us and getting access to people like Bernie, Chris, and myself to help you deploy and manage your cloud infrastructure. So the way that works is that we can help you with support. We can help you with architectural guidance, best practices on how to leverage some of the tools that we're going to talk about today, and we can also deliver training. And so these are the things that on a day-to-day basis we're helping our customers with. I'm based in London, where I run one of our 3 UK pods. And Chris, why don't you introduce yourself?
Yeah, I'm Chris. I'm a cloud architect based in Germany. I'm focused on the data stack, all things data, as I like to say, preferably on GCP. So I really like playing around with BigQuery, Google Cloud Storage, Dataproc, Dataflow. These are kind of my tools of choice. Bernie, you want to continue?
So then go next. My name is Bernhard Weisshuhn. I'm staff cloud architect for DoiT in Germany. I'm more of an all-around guy with a bit of a preference for infrastructure and notably Kubernetes. That's why I'll be covering the infrastructure section. And I guess we'll jump right in with me talking a bit about what I subjectively found interesting about announcements on Cloud Next regarding infrastructure. So I have a bit of a short list of stuff that I thought is worth mentioning. Maybe it's not the things that I'm most excited about, but it's definitely interesting stuff in there. It's really hard to prioritize all this because it was a lot of things. Some of them already known, some of them we knew before but couldn't really talk about. So let's dive in. Anthos now supports VMs, which will probably be a big deal for people who still run these things and who want to have one single pane of glass and one control pane for all their things that they run. So Anthos is not for containers, or not only for containers anymore, but also for VMs. That came along with these assessment tools, fit analysis, whether your workload can actually be containerized, stuff to help move things from your on-prem installations into the cloud. So there's a lot, obviously, around Anthos, and I'm not going to go into all the details of that. There is the whole distributed cloud thing where you can really see and thus stretching into all the little edges where, quite literally edges, where it's not been yet. So that's pretty exciting, but this is also a huge topic that probably would be a bit large for this. But one thing that Chris alerted me to, because he thought was really exciting, is the Cloud IDS. Google finally has one, and it works by traffic splitting or mirroring to a mirrored network where Palo Alto networks will inspect the network traffic and give you all kinds of alerting. And this is really the best-in-class IDS as far as I'm concerned. So this is huge for customers who had to run their own IDS solution so far, or were waiting for one by Google. Another interesting thing is log analytics. So Google has made it much easier now to basically export your logs into BigQuery and query them with a BigQuery front end that's specifically tailored towards log analysis. So you have query interface and you have response that is actually your logs, but you can use all kinds of funky BigQuery capabilities to do that. So if you have ever tried to make sense of an autoscaling log, for example, and to figure out why autoscaling worked or did not work, and try to connect all the little pieces, and spend like hours or maybe days to figure out what's going on, this is going to be a lifesaver for these kind of situations where you really need to dig in and make sense of disparate parts of log messages. So that's probably a pretty cool thing.
And maybe one thing I can add to that, kind of as a preview from the data section later, BigQuery has another feature that really goes hand in hand with this, is that it now finally has search indexes. You can actually search across multiple columns with full text search, and these also support JSON data types. So the new JSON data type on the BigQuery feature that came out, we just keep going like this all the time now. But it allows you to go over multiple columns with full text search, and these indexes are auto refreshed as you ingest data. This obviously is great for these kinds of log analysis cases that Bernie's talking about.
Can I throw out my Elasticsearch cluster then?
Well, in parts, if you want to, depends on what your organization requires, right? But at the same time, Google also now introduced a native integration to Elasticsearch from Dataflow, actually. So if you're currently struggling with loading data into the Elasticsearch, Google makes this much easier as well. So it kind of depends on what you're looking for.
Do both.
I'm really looking forward to that data section that's going to be coming soon. I'll just run through my list of. We're still not with my top 3. This is still, the runner-ups and
just teasing us, Bernie. Teasing us.
Yes. So it's gonna be even more exciting. So for those of you who use Apigee, you probably and if you use stuff like React in your front end, you may have struggled with the fact that there wasn't any GraphQL support, and now there is. Yay! So it's no longer just REST and gRPC. This native GraphQL support in Apigee for certain people, and it's not a few who use GraphQL. This should be huge. Another thing. We're all over the place now. This is really just my short list. So from Apigee, we're now back to GKE. Autopilot has recently been announced, where Google takes care of managing all your nodes. But there was always a bit of a delta in terms of features that were supported. There still is a bit of a delta, but that delta just got a whole lot smaller, because you now can have mutating webhooks. Gatekeeper for policies, what's the word? OPA, Open Policy Agent, and also committed use discounts for your autopilot managed nodes are there. So there's really no downside in terms of cost anymore. That's pretty cool. Let's talk a bit about tooling. Cloud Build is now Salsa level 2. What's Salsa? Salsa is a framework developed by Google that aims to minimize the attack surface for supply chain attacks. Basically, will secure the whole software development lifecycle by making everything signed and auditable and reproducible. So you can tie that in with stuff like binary authorization, which has been with GKE for a long time, but you can make sure that you can only run stuff on your cluster that has been built by this compliant pipeline on Cloud Run. It's not a surprise that Google is the first company to support this because they basically invented Salsa, but it's still a very cool thing to see that there is movement to address these supply chain attacks, which we have seen a lot recently, and they are quite devastating when they work. While on the subject of Cloud Build is using a framework called Tekton, which runs on Kubernetes and is a CI/CD framework. And now with Cloud Build Hybrid, you can have hybrid pools. That means you can build on any other infrastructure where you can run Tekton. That means Kubernetes. So if you have Kubernetes running somewhere where you have nodes that have a certain capability that you need for your builds to function, you can build there all from Cloud Build. That's pretty cool, I think. Serverless. Cloud Run now supports applications built for Spring Boot, ASP.NET, Django, and some others. So there's even more support for just taking existing applications and throwing them on Cloud Run, and they should just work, which is cool if you have these. And speaking about Cloud Run, this has been around for a while, but it's probably worth mentioning that you can now provision CPU outside of your request cycle. So you can no longer just run workloads while there's an incoming request, but you can also have continuous CPU running. You can have jobs executing for far longer than before, 60 minutes. You can use up to 16 gigabytes of RAM. All of that shows Google's commitment into the Cloud Run platform, which is pretty awesome because in a lot of cases, Cloud Run is actually enough. You may not need GKE for a lot of cases. Next up, Beyond Corp Enterprise. Whoever worked with Beyond Corp Enterprise, that proxy that sits in front of your enterprise level applications on-prem, for example, to give you zero trust infrastructure. You don't no longer have to rely on perimeter security, something like that. Whoever worked with that and had to debug something that was not really working because your on-prem setup was really funky and the network design was from the 90s and it was really hard to figure out why things did not work. There's now a policy troubleshooter that should help you debug these situations because by definition, these are usually pretty complex setups. So for practitioners in the field, this should be really useful, and I'm going to have a look at that as soon as I can. There's other things that announced around Beyond Corp Enterprise. The app connector is a different way of connecting your on-prem things with Beyond Corp Enterprise. If you are thinking about Beyond Corp Enterprise, you definitely want to check on that because things have gotten a lot more transparent and easy recently. We're almost through with our honorable mentions section. One thing that caught the attention of my colleagues here at DoiT was a new type of persistent disk. I think the name was efficient. And it is efficient for some definitions of efficient. So it has high throughput, I think 2000 MB per sec, but it has a surprisingly low IOPS rate. It was 1200, prompting response from my colleagues whether this is implemented by floppy disks. So the use case should be probably big data, log analysis, cold storage, where you write once and you write a lot in one setting, but you don't want to seek a lot or do random writes on this. But for that, it should be pretty cost efficient. And the last thing on the runner-ups honorable mentions list is edge security policies. So for edge nodes like CDN, you can now define security rules that can filter traffic. So far, it's limited to IP addresses and geographical ranges, but it may still be useful if you need to comply with some local regulations. So you can offload stuff in CDN and still make sure that it can only be accessed from countries where it's legal. That should be useful as well. And that's the short list. Now we come to the real the real winners, in my opinion, like the stuff that's very noteworthy and pretty cool. So my third place, so to speak, is the managed service for Prometheus. Prometheus, which is the ubiquitous metric scraping solution that everybody is using, is also built into GKE. Like the format has really become the lingua franca to export metrics. But running the thing yourself is very easy in the beginning and can become a nuisance the larger your installation gets. If you have multiple clusters, you then start sharding your collectors, and then you reconnect them with was Thanos, I think, and then you cluster those up, and it becomes an operational overhead all on its own when it was supposed to just support your operational work. So that's why I think a lot of people will be very happy to see that they can now have a Prometheus installation that's just been run and managed by Google. It's not actually Prometheus. Some parts are. Other parts are just a conversion layer to the underlying infrastructure, which is Monarch, I think. Yeah, that's stuff that's below Stackdriver and Cloud Monitoring. But it gives you full compatibility for the protocol. That means all your things that extract data from Prometheus will just work. Your Grafana dashboards will just work without any changes. The way you expose metrics can just be the same thing. They'll just be collected by Google and fed into the same system. So you can even retrieve your metrics through cloud monitoring or expose them via this Prometheus service. This is all pretty cool and ties in, or it's a bit parallel, I think, to the GKE workload metrics that have been also announced earlier, where your applications in GKE can expose their Prometheus metrics and Google will just collect them and put them into monitoring and make them accessible to you. The pricing is going to be based on number of samples. And if you know Prometheus, you know that this is where probably a bit of risk lies, to be honest, because if a developer adds some high cardinality metric, IP address or something, that this could really blow up the number of samples there. So it is not an excuse not to keep close tabs on what metrics you expose and what you use. It supports all kinds of filtering to make sure that you can react to things when things go wrong, but you shouldn't just use it completely unsupervised and without any thinking, because this could create a lot of cost. But it's definitely a lifesaver for people who struggle with their large-scale Prometheus installations. And I can see a lot of our customers be really happy to try that out.
Awesome.
Gotta
ask a question that when you say managed, it's not serverless, right? Do we have any insight already how and where this is running?
Depends. You can actually run this in multiple ways. So I think depending on where you want to, I'm a bit out of my depth here, because I think I may be confusing it with GKE workload metrics, which are supported since Kubernetes 120. And these you can also, if you don't run that version, you can run a sidecar that will expose these things. I'm not really sure how the implementation for the managed Kubernetes is. I don't think you need to run anything yourself. you may be running. You can still run the Prometheus operator to collect your data, but the collector is going to be run by Google, and it's going to be stored inside Google, inside Monarch. Okay, then number 2. It's kind of an odd choice, because is this infrastructure? Is this really a cool tech announcement? I think it is. And I think everybody should find this cool. It's the carbon footprint reporting that Google introduced, and it's a lot more than just slapping some sticker on a web page saying we're carbon free or something. Google is carbon neutral already, but they're doing this by buying all kinds of offset certificates. They're committed to getting this number down and to do less with certificates and more with actual renewable energies. And they're very open about this by offering the metrics for any service you use. So you can have detailed reports about what your carbon footprint is by choosing these and these services. You can so by this, Google supports companies reach their own goals in becoming more environmental friendly, and they also try to nudge you towards certain friendlier decisions. For example, whenever you pick a region now, it will tell you like, this is a region with a high carbon footprint and this is a low one. There's also a nice region picker that they implemented where you can say, okay, my preferences for this workload that I'm currently thinking about is low latency because it's a batch job, I don't care. But cost is obviously a factor, and carbon footprint is neutral, whatever, or my preference is this to be very low, and then can advise you based on your location or location you choose what region to choose to optimize these 3 things. That's pretty cool, and I think just offering that will probably have some trickle-down effect, that it gets into people's minds. They did some study that said from existing users, 19% will be influenced by knowing the carbon rate or the carbon metrics, and for new users it's actually 50%. So I applaud Google for this effort. I think this is not just corporate greenwashing. I think this looks like a really serious attempt to bring down their emission footprint and help companies to do the same. So that's why this is on my list, even if it's not a cool infrastructure feature per se, but it makes the whole infrastructure a lot more cool, if you want so, and cool being a pun about global warming. So that's been my top 2, and now you all are shivering with anticipation. What would be my pick for the most important or the most interesting infrastructure feature that I saw on Google Cloud Next? And for me, it really was the next generation load balancing. And for some people, this may be a bit anticlimactic. It's like, oh, yeah, what does that do for me? But the thing is, it may not do a lot of things for you right now, but the things that it enables are crazy. It's a bit like introducing eBPF to the Linux kernel, or what we've seen with Dataplane v2. The potential for things and products to be built on top of this is great. So what's next generation load balancing? It's basically using Envoy, which is a quite known proxy implementation that is being used inside of a lot of service mesh implementations like Istio. It's using Envoy proxy as for load balancers and supports the internal configuration protocol of Envoy to talk to other load balancers and proxies. So what that gives you is you can have your own Envoy proxy somewhere. You can have multiple other internal load balancers, and you have an external load balancer. They all run Envoy, and they all speak this XDS suite of protocols. And now you want to shift traffic from one backend to the other. And all these load balancers point to this backend. you can, with one operation, reconfigure all these load balancers to start shifting traffic to another backend. And this is just one example. There's a lot of features that are being implemented on top of Envoy. That's weighted traffic splitting, fault injection, request mirroring, outlier detection, request retries, all these circuit breakers, CORS support, other types of session affinity, header transformations that are much more powerful than the stuff you can do today, new load balancing algorithms. It really opens up a lot of power to a technology that's already very, if you ask me, advanced and ahead of the competition. Like Google's load balancing, the Anycast implementation there is really, really cool, and adding like a ton of features on top of this is really exciting for me, at least as a practitioner. This is the things that you want to work with, stuff like requests, retries, for example. Being able to do that on a load balancer level will solve a lot of use cases where you had to come up with some hacks in the backend. You can do this on a load balancer level now. I'm really excited about this, and I can't wait to get my hands on this. And it opens up a lot of enterprise use cases as well, like hybrid load balancing, as I mentioned, where you have load balancers on-prem, and they all need to be synchronized. You can do stuff like Cloud Armor for on-prem solutions now, or actually add CDN features for your on-prem things, because they're all these load balancers can form a mesh. That's really, really awesome. So I'm skipping over some of the other tangible effects I think this is built on, like Private Service Connect, stuff like that. There's definitely a lot of cool things happening in the networking space currently with Google, and that's why I picked this as my number one infrastructure feature, although it didn't get really the attention, and this is one more reason to really point that out and draw some attention to it, because it really wasn't featured in any of the keynotes, but I think it should have. So that's me. That's my infrastructure wrap up. Hope you liked it. If you have any questions, shoot.
So honestly, the net load balancing next generation approach, I think that sounds really interesting. But as someone who's not coming from the networking side, doesn't that make that everything more complicated now, or does it actually make stuff easier?
I don't think you'll be forced to use any of those features, right? You can just use this as a layer 7 load balancer as you did before. But when you used to work with them using URL maps or some header transformations, there were some limits that you would hit, and I see that these limits will all go away. So I don't necessarily see this as a that load balancing became a lot more complex now. I think you can build really complex beasts with that. That may be a bit of a danger there, but I'm more excited about the flexibility it will give and the reliability as well, and observability. The metrics that you can see from this are also going to be a lot more interesting. The deployment scenarios that you can do with the traffic splitting, the security features you can do with that, I think they all outweigh the dangers of this becoming too complex. You can always go back to the low feature set, which is also already quite advanced, I think.
So it's more about options. I guess it'll be quite exciting to see how some of our customers leverage the feature to deliver their environments and stuff. And it's one of the fascinating things about working at DoiT is getting to see how people build that sort of internet scale infrastructure and services for their customers in different ways.
Absolutely. So who's next then? I guess I'll be handing off to Chris for getting his insights on the data announcements.
Yeah, that's good. All right. Finally, we get to talk about some data topics. There's a long list of amazing announcements. Some of them you might think, well, this is a small announcement. Yes, they are a small announcement, but these are great announcements to finally tie the data platform together. There's a bunch of small things that really make a lot of these huge building blocks work together finally. I also, of course, have a top 3, but I also have a long list of honorable mentions that have to go through. I'm sorry, stick with me for a minute. I'll keep it short and sweet. The first one is the first section of these honorable mentions. Actually, it's just on BigQuery. That's a great video just on what's new in BigQuery. And if you've been a BigQuery user over the last couple of months, probably 1 to 2 years, you have been in a land of happiness. There's been so much awesomeness coming out of BigQuery over the last couple of months. They have just been crazy with new features and at the same time making BigQuery significantly faster. Just out of curiosity, run a query that you commonly run from the UI and you remember execution times you had probably a year or 2 ago. These execution times have gone down significantly. I used to tell customers, well, you rarely see a query execute below 5 seconds. Well, you regularly see queries now execute below 5 seconds. And 1 to 2 second queries are like normal now, even for larger queries and more complex queries. BigQuery is constantly evolving, both in the stuff it always could do, as well as in the stuff it can do additionally now. So let me pick out a few. Obviously, BigQuery Omni is going GA, it's almost like a footnote that this is finally GA, but it's huge. And not just for the query part, where you can query from BigQuery data in AWS or data in Azure, and it also allows you to copy cross clouds with BigQuery. Now, you can basically copy a table that relies on an AWS data set into GCP just straight from BigQuery. No more ETLing, no more VPNing, no all that kind of stuff. It's just boom, just copy it and you're done. Authorized external tables, like authorized views, but with tables. You don't have to give every user of the external table access to the underlying resource anymore, right? How many cases have I seen where customers were using Google Sheets as external tables and forgot to add every user of the table also as a user of the sheet? And this is now going away with authorized external tables. BigQuery external functions. We all know UDFs. You might have seen them in the docs and ignored them because the syntax is weird, but you are always able to define your custom logic in either SQL functions or even JavaScript functions. Now you can use cloud functions to execute external logic. This allows you to write your logic, your external logic in whatever language that cloud function supports. You get all the runtime characteristics of cloud functions, and you can plug it right into a function within a BigQuery SQL statements. That's pretty powerful. BigQuery Migration Service. It's basically a way of translating SQL at scale into BigQuery standard SQL. So again, something I've done a million times, scanning millions and millions of rows of some other SQL dialect that's not very BigQuery compatible, just to change some string concatenations or change the order of arguments in a date function. BigQuery Migration Service does this for you now at scale and through the UI. It's amazing. There's been a lot of BigQuery administration. A lot of that you've probably already seen in the UI, like analytics around how your resources, especially reservations, are being used. And it now also has a slot estimator. How often did I get questions from customers? Am I ready for slots? Well, look in the UI and UI will tell you how many slots you should purchase. It's overdue. BigQuery JSON data type, or already mentioned some of that in connection to other features where this kind of goes hand in hand, but JSON data types are now a native data type. It's not a JSON formatted string type column anymore. It's a native JSON data type in BigQuery. This goes hand in hand with the search indexes that BigQuery now has announced. Search indexes allow you to search cross columns with full text search. And these search indexes are all updated as you continue to insert new data. Really, really powerful. And yes, this also supports searching in JSON data type columns. Very powerful, especially in the combination. Think of log analysis and all these kinds of scenarios. And then one thing I have to mention on my short list, the BigQuery Storage Write API is also now in GA. We all know, and many of you love the streaming insert API, what we've seen so far. The API method is called insert all. This one has much improved throughput. You can write up to or more than a gigabyte per second, not up to, more than a gigabyte per second. You can write in binary formats like protobuf. You have transaction control over multiple workers to writing in parallel and then committing all of it at once. And lastly, it's 50% cheaper than compared to the old API. So it's better, faster, and cheaper. Take a look at it. It's a little more complicated to use because you have to manage a few more connections, etc. So it's not a in-place transition from the previous one. But once you make the effort, you have a whole suite of benefits. And this is probably also the API that Google is going to move forward in the future with new developments. So that's my BigQuery honorable mentions.
Wow,
on
that's
the
exciting.
It's quite.
If that
a bit
was the
already.
honorable mentions. I can't wait to hear the real short list.
It was really difficult for me to pick a short list, a top list. Yeah, well, you'll see. One more thing I have to mention. It's not BigQuery related, but generally streaming analytics related. Dataflow Prime. So now a serverless Dataflow environment that has much improved autoscaling. So first of all, it not only supports horizontal scaling, give me more notes, but also vertical autoscaling. It can increase the size and the shape of individual workers in your worker pool. Plus, right fitting, as they call it. Right fitting allows each stage in your pipeline to get its dedicated resource pool. So if you have a pipeline that at some stage requires GPUs, currently you would have to give the entire pipeline GPUs. With right fitting, Dataflow Prime can automatically assign the right resources only to the stages where they're really used, and you really can reduce cost this way. Plus, the diagnostics and recommendations around Dataflow have improved significantly with Dataflow Prime. So take a look at that. There's a really nice blog post out on there as well. And I think, yeah, these are my honorable mentions list. I gotta say, and this is more of a meta honorable mention thing, but Cloud SQL also has improved significantly, not just for the amount of dropped features or added features, but also for its overall performance. Google has made some numbers available how downtime actually has reduced, and it's extremely good downtime now. And overall, the service has developed so much, like Postgres, for example, supports 142 database flags and 44 extensions now. Yes, this is still a managed database, but you can do so much with the managed Cloud SQL for Postgres offering. IAM database authentication that really recently came out, logical replication and decoding, the Cloud SQL Insights and the SQL commenter, where you can now, if you're using an ORM, the ORM now automatically adds, for example, trace IDs or annotations around what workload actually created this query. So you can now get, and this again, a blog post with great screenshots, you can get a trace view within GCP and not only see latency of the request and then the spans and traces that you manually created, but you can also see how long the database queries in these traces ran and what exactly kind of query was executed. And you can get to that both from the trace ID, but also from the Cloud SQL Insights view into the trace. I mean, the connectivity is crazy. And also, if you want that based on the open trace standard, but also just plain annotations that kind of like key value metadata, basically, whatever you prefer.
Wow. Is that open telemetry based? Or
Yes, it's open telemetry based.
Cool.
Awesome. Let me get into my top 3. And starting from number 3, I have to give another BigQuery feature stage here. BigQuery AutoScaling. How long have we been waiting for this one? Traditionally, you would either commit annually. Now, then they opened up monthly. Then they opened up Flex. And with AutoScaling now, you can commit to Flex slots, and BigQuery automatically detects usage of these slots and increases your slot commitment or decrease it, depending on usage, with an upper bound and lower bound, so that your workloads can kind of organically consume the right amount of slots and you still have cost control in these slots and probably have better pricing. It's a really nice balance between staying purely on demand and committing to a fixed amount of slots and still putting a price cap on your BigQuery usage. I've had a lot of customer conversations where this was basically, can we build this ourselves? Well, yes, you could. In the past, but it was really slow and not perfect. Autoscaling for BigQuery slots is probably the perfect solution. Now we're really excited to onboard a bunch of customers on this.
Awesome. Yeah, I think that's going to be a big help for all of our customers. And I think any sort of situation where those micro optimizations that are really outside of the focus for your team and for your business are just always great wins. So wow.
Yeah. Number 2 on my top 3 list. Number 2 goes to the Postgres SQL interface for Spanner. Yes. Google has made a huge commitment towards the Postgres SQL interface. They see this as potentially a next unification step for SQL interfaces towards applications. They compare this really the way that Linux standardized operating systems, the same way they're seeing Postgres taking over the future here. And with it, they're now offering a completely non-Postgres SQL interface to Cloud Spanner. So what that means, you can use a JDBC connector or whatever standard tooling you have for Postgres to connect to Spanner now. And this makes migrating to Spanner much easier because your team ideally already knows and has existing tooling around Postgres that can just be transferred to Cloud Spanner now. Of course, for an existing application, be careful. It's not a one-to-one comparison. Of course, the underlying database has different performance characteristics than a instance-based traditional Postgres database would have. But the interface layer, unifying that already is a huge benefit. Think of all the ORM methods, etc., that can potentially reutilize, all the tooling that is available out there for Postgres that can be utilized with Spanner. Take a good look at this. It's very likely that Google is going to continue to invest in the Postgres interface a lot.
Yeah, I'm super excited about this one as well. I think in combination with the recent update that they made so that you can use Spanner processing units, so you can have a less than a node for Spanner. Spanner's probably one of Google's most expensive database options because it does so much. But I think with the addition of that ability to kind of enter and start using Spanner at that lower price point, this is now like a killer feature because you can take your mediocre sort of Postgres data, maybe that's going to scale up, and you can leverage Spanner through Postgres to do all of those interactions that you need. So I think whereas previously most customers went for Spanner as a very much like high like a large data kind of challenge with a lot of those kinds of consistency requirements and things. I think this now sort of like peeks the door open for maybe that next project that you're using Postgres for. You could think about using Spanner underneath, because if you really need to scale up over time, Spanner does that in a very straightforward way.
Absolutely. It's really a cloud native relational database. There's a really nice architecture session as part of I think it was a breakout session as well as part of the Cloud Next. And it nicely explains the architecture elements that Google has been using to build Cloud Spanner. And to be honest, it's very much similar building blocks like Bigtable or BigQuery, but there are a few additions that really make Spanner work like that, especially with global replication, etc., and the kind of investment in having very, very, very accurate clocks on all the data centers, etc. Super interesting if you're into databases, especially relational databases. Take a look at that.
And I think for that use case as well, maybe where you've got very a lot of seasonality in the demand on your database instance. Cloud SQL, it's a great service. Obviously, runs Postgres natively as well. You can do that, like you can spin up read replicas and do that. But I think Spanner makes that with just 30 minutes of pricing increments for the units that you're running. You can scale up your database if it's busy at the weekend, scale it down on a Monday morning, and you can really sort of hollow out that pricing curve as well. So yeah, I'm super excited to work with some customers on implementing that with them. I'm so excited about number 1 though, because we've come. I feel like in the data space we've covered so much stuff already.
Yeah, my number 1 for the data space has to be Dataplex. Dataplex at first sounds a governance feature, seriously, but wait. Dataplex now finally ties together how you can use all these power engines for working with data in the Google Cloud. It is a centralized UI at first. It's the main way you're interacting with it, that has a bunch of really advanced features. The first thing, it automatically harvests metadata and makes it available in a unified centralized meta store. So it means it automatically detects the data sources that you have, and it reads, for example, if you have a Parquet file, it can read the schema from the Parquet file. Obviously, it can do that from BigQuery tables, but being able to do that from files is really pretty powerful. It can automatically run data quality checks, and Google will apparently provide a long list of templates where you can just with a couple of clicks check certain conditions of the data, and then that will also be flagged and clearly visualized if these data quality checks have passed. And similarly with the data checks, there's also going to be other templates for general data lifecycle management. So data might be getting out of date or should be archived, etc. All of that kind of stuff is now centralized in Dataplex. A lot of these features this is not feature-wise, this is not huge, but what it does conceptually, it removes the requirement to also look at the data where it is stored, right? If we're setting up BigQuery environments with customers, we typically recommend them, you need a storage project, you need an analytics project for that, you need a long-term storage project. Every team maybe should have their own storage project. And all of a sudden you have tons and tons of places where data is located potentially. And that's just for BigQuery, right? Take Google Cloud Storage, it happens much easier even to federate that out. The power of Dataplex is that it brings it all together in one place. And that it really doesn't matter anymore where data is stored. It's all going to be in Dataplex. And now wait for it. You can run BigQuery queries, start notebooks, or start Spark jobs from Dataplex. Yes, and think of the Dataplex UI as having an embedded BigQuery UI, or an embedded Spark UI, or an embedded Notebooks UI. It's right there, especially with a couple of clicks. If you think of the BigQuery UI, on the left side, you have the resource tree. Now, you click an element in the resource tree in Dataplex, just similar to BigQuery, and just opens up an overview meta details page of the resources. But then there's a button, run a query, open a notebook, run with Spark job, right from Dataplex. So it really ties that whole loop together. It's unifying by cataloging, basically, something like data catalog, but with much more power, with much more smartness. It's checking data quality checks built in, a lot of smartness. It's managing the data lifecycle, and it's making it actionable all from one tool. In the past, if we were talking about the data stack on GCP, it was a bunch of tools. Now it's finally a unified experience called Dataplex.
Awesome.
Wow.
And so you mentioned sort of Spark jobs as well. So I guess something that you haven't touched on, but I thought you might. But it's why it's exciting to do these things live. Is Spark on Google Cloud. So does that mean that Dataplex and Spark on Google Cloud sort of integrate sort of natively? And I guess I'm sorry to steal the thunder, but I should maybe introduce what that service is. So this is a new service that, whereas I think with customers in the past who've been working in Spark, they've mostly had to spin up their own Dataproc cluster. And obviously then best practice around that is managing it ephemerally, so it shuts down and you're not using these big instances once you're done. But now, you can use Spark in a much more serverless way, with much more closer to a no-ops kind of service, and you can run Spark jobs.
It's a really powerful feature. It basically takes away the need to spin up a cluster at all. It's really truly serverless. And I mentioned if you compare this to Dataflow Prime, it's very similar in the way that it can run, right? Dataflow used to also be a service that spins up in VMs in your environment, and Spark Dataproc would do the same thing. Now, with both being serverless, Spark really goes the same way. This is groundbreaking in the way that any other cloud was able to run Spark previously. But to be honest, at the same time, there's not too much specific yet how this can. I'm sure the underlying technology is going to be scalable and cost effective and all that goodness. But what kind of differences this is going to make on day to day, we don't know yet much about. So I'm really excited to talk more about this when we know more.
Yeah, and I think it's just great to have options as well. So you mentioned obviously Dataflow, we've got Dataproc and this new Spark approach. And so I think the answer, a lot of customers sort of say, which should I use? Where should I do my ETL data processing? It's like, well, it depends, and the right tool isn't it's not like the Highlander prophecy that there will be one to rule them all. I think having those options and having that choice. If you're a Spark team, there's now a really nice serverless way for you to migrate your workloads to Google Cloud and start using Dataplex and have a play with BigQuery. These are great sort of avenues into leveraging the service to its maximum. Awesome.
Talking about things you didn't mention, I remember seeing something about big table autoscaling, not just BigQuery autoscaling, being announced to, I think, even like predicting workloads or something and adjusting the size of your cluster. Is that am I wrongly excited about this because I'm not really the expert?
Great thing as well, definitely. The big table is always able to very dynamically add and remove nodes from a cluster. And auto-scaling is a natural evolution, in my opinion, from what it can already do. I'm sure there was a lot of groundwork that had to be done to make this really possible the way it's possible now. But it's doing exactly what you said, Bernie. It scales up nodes in your cluster depending on the workload in your cluster. And it goes up or down. That's what auto-scaling for big table can do.
Okay, but now I get it. Why it didn't make the list. It's like, well, why didn't we have this long ago, right?
Well, in a way, yes, and I think this is in a way true for many of the announcements that we see in this year's next event, right? I remember last year and some other years previously, we had long lists of hundreds of announcements, and a lot of them were, "Wow, this is amazing! This is so cool! So when can I use it?" Well, you can, but you have to rewrite all of your workloads to the. It was great still, right? From a computer science perspective, they did amazing things. But now I feel like they're really bringing this together and really making many of these amazing features they've been working on for years usable for a vast majority of organizations.
True. So,
should we do the AI and ML wrap up? So I'm so lucky to have to be going last, I think, because you guys have done such a great job of sort of covering all of the things that I might have mentioned and learned a whole bunch, like listening to you and chatting with you along the way. So that's great. I think the one honorable mention that I'm super excited about as a bit of a data nerd is Google Earth Engine, and I guess this kind of links in a little bit to what you mentioned, about Google's sustainability and like its commitment to having a green cloud and you being able to report on how the impact of your workloads. And so Google Earth Engine, it's not going to necessarily just be open to everyone. It's going to be enabled for some of Google's largest customers to leverage. And I'm really excited to see how this gets used, because it's sort of one of those services where I can't really see right now exactly how companies are going to integrate all of this data. But essentially, it allows you to run geospatial analysis on data sets that Google have. These are sort of data sets like things like climate data, weather data, and seamlessly join them with APIs. It's a Python API. PyData, and that's going to allow you to leverage BigQuery and other data-centric Google tools to combine your data with say some atmospheric data to understand how that's working. And I think there's going to be some really interesting stuff that comes out of this. I mean, if you think about things that are going on in the news at the moment, obviously flooding, container ships being backed up, and so I'm super excited to see some sort of not just big companies analysis, but like hobbyist researcher kind of research into some of these trends that we're seeing, and maybe helping us to address some of those issues. So that's my kind of honorable mention. And moving into my top three. At number 3, so I think, like in general, the story for the AI/ML announcements this year is I feel like they were quite incremental. The biggest announcement for Google Cloud AI and ML this year was Vertex AI back in May. But I think all of the things that I'm going to cover a very much like an incremental, like kind of improvement in the capabilities and the options that you have for delivering machine learning AI solutions on Google Cloud. So in at number 3, I've got the document AI expansion to include contract documents, and so this is going to let customers extract insight from unstructured data, but specific to things like contracts. And I think this is sort of very in the zeitgeist of everyone's working remotely. I remember this is the first job when I joined DoiT in March 2020. I'll always remember that, and lockdown, of course. That contract, that DocuSign contract that I got from them was the first kind of real electronic. I didn't need to physically sign this thing. And I think obviously this is now, the modus operandi for most companies. And so I think having a tool set and a machine learning approach that allows you to manage all of those documents at scale is really useful. And so what the contract AI tooling is doing is enabling you to not only index all of the entities and extract those out, but also capture things like who signed what document on what date. So you can collect information about who signatories were, link entities across your organization, so you understand what's been agreed to, pull out specific terms and these kinds of things. And we've actually had since I've been working at DoiT, customers that have come to us and say, look, we do so much of our business via contracts. We'd love to have an automated way to leverage this. And your option previously wasn't a terrible one. You could use AutoML, natural language, to do that. But what Google have done, over the last year, is to really add a lot of value to that AutoML solution out of the box for you, so that you don't need a research team to be able to sort of get some of this insight into your contract data, so that you can start to understand what your risks are and what the opportunities are for the contracts that you've got.
One thing that I saw in the demonstration that really impressed me was where they inferred stuff that was actually not written out in the contract from the knowledge graph to say okay, we recognize this legal construct, and this I don't know, the runtime is two years or something. That's whoa, we're getting closer to the singularity here. I'm not sure how much we can trust this automatic lawyer there, but if you have ever tried to extract meaningful information from a contract that was somewhere hidden in there, I think this is going to be hugely useful. We're going to see a lot of products and possibly new companies leveraging these things.
For sure. And I think some of these, BERT, I imagine it's using a BERT architecture under the hood. Yeah, they can be really impressive for getting some of those long range dependencies and extracting these kinds of insights. So I think that could almost just be a turnkey solution for a lot of companies. If you've got a bunch of contracts, it's quite straightforward to sort of start with this. It is in alpha at the moment, but I think definitely to watch this space.
And I gotta ask, Bernie dropped the word knowledge graph on us here. Does that mean, is this the Google knowledge graph, or is there something coming around a customer specific knowledge graph?
I thought this was referring to a Google internal knowledge graph, but I'm not sure whether you can tap into that and add your own stuff. Don't really know.
Yeah, not too sure. Maybe you're thinking of Cloud Next 2022.
Sorry if I was going ahead there.
So my number 2 entry is CCAI, Contact Center AI. So I think specifically what's sort of changed is the ability to monitor your conversations and your interactions with your customers at scale. And so that could be not only via something like Dialogflow, if you've got a smart agent running on your website supporting customers with their FAQs and these kinds of things, but also if you're running a call center and you've got natural language, you can use something like speech to text to convert that speech into natural language that's written, that you can then run again a state-of-the-art BERT-like model against to do things like categorize the kind of the themes in the conversation. So as someone who's managing a contact center, can we start to understand what kinds of conversations we're having with our customers? Can we sort of monitor and understand the themes that are happening over time? And again, I feel like this is very sort of germane with the people can't go to their bank, to their energy company and speak to them in person anymore, and so you're going to be operating in much more of this mode. And so Google providing inside GCP the tooling to help businesses to meet the customer where they are and leverage these sorts of things is great. So being able to say, for example, what was the topic of this call, like topic modeling, and that sort of seamless ability to convert not just those smart agent conversations via dialogue flow, but also natural language. I think this is going to be really useful to sort of help and empathize better with customers and their needs.
Anything that can improve customer service in a call center situation gets thumb up from me. I think there's still a lot of improvement there to be done.
Yeah, and I think just just sort of seeing the not so much necessarily where the technology is, but also that trajectory. So Dialogflow has been around for a year or so on Google Cloud, and I think this really just demonstrates it's going to become a real focal point for a lot of those kinds of interactions, all of those tools that they're getting built around it. So again, if you're working in the contact center sort of space, you're running smart agents, I think this could be a great way to basically just import the data. The tool supports single conversation upload, but also batch uploads, and you can start to sort of see like what the tool provides in terms of highlights, in terms of that topic modeling that I mentioned. So that's number 2. And I probably gave a bit of a hint with my mention of Vertex at the top of my section. But I think for me, and again, I think this is another example of incremental improvement, is the introduction of Vertex AI Workbench. And so Vertex AI is obviously Google Cloud's new, pretty new, since May this year, AI platform for running all of your ML needs, everything from organizing your data, training a model, and then making it available for inference. But what Workbench is all about is that sort of IDE that your data scientists, your machine learning engineers are using every day. So obviously for a long time we've had AI platform notebooks or Vertex AI notebooks, which essentially are just a virtual machine running on Compute Engine, maybe with a GPU attached that that you're spinning up and working with via Jupyter Hub. What sort of Workbench is doing is it provides this this new concept. If you go today to the previous Vertex AI notebook section, you'll see two tabs. You've got user managed notebooks and you've got managed notebooks, which is in preview. And so this managed notebooks is all about moving away from that concept of having a virtual machine underneath that maybe even you can SSH into, to a kind of a more serverless kind of approach where you can dynamically attach hardware as you need it. And for me, like a lot of my colleagues, friends that are working more in sort of the research domain, they're really familiar with Google Colab. And I don't know if people are familiar with the Google Colab model, but I was quite enjoying some fun Twitter feeds on during lockdown with people talking about how they've been trying to acquire the most powerful GPUs that they can on Colab so that they can run their training, and there's some fun hacks there for kind of restarting your instance until you get the GPU configuration so you can train your state-of-the-art BERT model. But I think what Vertex AI Workbench is sort of doing is it feels to me like it's getting a little bit closer to that Colab model where you've got a Jupyter notebook, it's got your containers and your dependency in there, you've got the flexibility to attach the memory or the GPU that you need. It's very seamless to scale up the instance, and I think it sort of it gives options to teams working in the machine learning space to sort of play to their strengths. And so if you're an excellent researcher and you know how to build models, but you're a little less kind of comfortable working with environments and provisioning machines, then I think this really fills a gap for you. And like I think there's a bit of a flame war in the ML community around whether notebooks are valid production sort of artifacts, and some people are very much in the kind of no way is my data scientist's Jupyter notebook ever making it to production. Some people are more are more relaxed about it, but I think this gives you a nice kind of middle ground, so that you not only can you build a proof of concept and start to do some coding and process some data, but you can go all the way up to training a SOTA kind of model, state-of-the-art model, using the attached accelerated hardware. So I think for me this is going to be great, and some of the functionality that it offers, I think is just really smart and really useful. Things like having an idle time where the notebook shuts down, so your DevOps guy is never going to come past your desk or grab you on Slack again and tell, why have you been running this notebook for 3 years? You can schedule notebooks to run, so maybe you want to train your model.
True. So that actually happened in the former company. That's why.
Oh, definitely, yeah. No, it's super common. So yeah, and the ability to schedule notebooks to run. Again, like I'm not necessarily saying this is something that every team will want to lean into. There are other sort of tools on Google Cloud for scheduling workloads, things like Cloud Composer. But I think it's nice to have options. If you want to think about how how you can schedule the workloads or the training or the transformations that you want to do on a daily basis.
Amazing. This is huge. Have you seen any kind of parameterization that comes along with the running part? Would love to. I've been spending quite some time with kind of getting the pros and cons out of for the Windmill is a Netflix solution, right? That's been often used around this. Is it basically a managed windmill, or does Google have a completely separate approach to it? If you've seen anything around that?
So as I said, my guess, and I don't know, is that I think this is a lot closer to the Google Colab solution, which has existed for like a number of years. I think it's very common. It's a very common environment that people use on the Kaggle platform when they're doing data science kind of competitions and stuff. So I think it makes it a lot more familiar, and it's just really simple pricing. So I won't repeat pricing on here because pricing is subject to change, but you've got some really nice tiers that mean that just the bog standard notebook that you spin up to do your initial EDA on a data set that you're working with is a very comfortable price point to get started. And the nice thing is you can seamlessly take that notebook once you've got the code working. You've run a couple of epochs of training, and you know that you've got the code right. You can attach a GPU, and then you can run your training then and save the artifact to GCS, save your trained model, and you don't need to worry because you've set an idle time. So when the notebook goes idle, it's going to shut off. So no more worrying about forgetting to turn that off. I think also obviously you've got all of the containers that Google manage. You've got things like R, you've got PySpark that's available inside of there. So again, just fewer ops for your team to manage. If you've got data scientists that are working in the R language rather than Python, then you can go with that. Obviously TensorFlow. You've also got other machine learning frameworks are available and will be erased from my brain. Those kinds of things.
But that's actually another huge hidden announcement that you're making there, right? There's now managed R on Google Cloud in a way, right? That's huge. Wow.
So being able to run different kernel types, I think is really useful. And there are certain things that like languages like R that probably don't get as much love in the ML community, like definitely in science and research, very very commonly used. But I think it's great to have that tool set and available.
All those pirates are going to be happy.
Yeah? So yeah, I mean, I think that's my top three. I love working with with Vertex AI and just its ability to sort of make that single stop sort of place for managing all of your sort of your data processing, your models, and the history of the models that you've trained and those artifacts, and then also what you've got running in production. And I think this is a really good thing to add into that toolscape. And so I'm excited about that. Okay, and so the astute among you will have noticed that we each provided a top 3, and 3 threes is 9. And so what's the 10th? What's the number one announcement from Cloud Next that we were sort of holding back? And I think from DoiT's perspective, something else that you should know about is obviously not only do you get access to sort of a wonderful team of knowledgeable architects across everything from infrastructure, data to AI and ML, but you also get access to our platform. And one of the tools that we've just announced that's come out and available for Google Cloud is FlexSave. And so this is an ability for you to take your existing compute engine workloads and benefit from an enhanced discount than that you'd get from something like sustained use discounts. So one of the great things about working on Google Cloud is if you use a compute engine instance for a certain period of the month, you can achieve a double-digit percentage discount just by using that service with no clicks, no changes. Google provide that discount to you as a thank you, or as a sort of a recognition of your continuous use of that service during the billing month. By using FlexSave, you can actually enhance that discount even more. And so what DoiT's able to do, because we're one of Google's largest reselling partners, we're able to actually make commitments against Google Cloud Compute Engine instance types. And so those commitments, because they're for over 1 or 3 years, achieve a much better discount than that sustained usage discount gets you just in that monthly period. But at DoiT, what we're able to do and offer for our customers is the ability to access those discounts, but without this 1 or 3 year commitment. In fact, there's no commitment required. What we can do is we can offer you those discounts on your compute engine workloads, and really help customers to get their compute engine bill down. And so we're really excited for across all of our customers, and we've got customers all the way from Australia down America, Israel, and Europe, the UK, of course, and so being able to offer them all in the regions that they're operating in those largest regions on those most common instance types, a significant discount over what they might be getting today with sustained use discounts, but with the flexibility of not having to worry about committing for a fixed period of time.
Yeah, to get
really get the benefits of commit without committing, right?
Yeah.
To get specific for a moment, what you actually get if you look up the prices or discounts, I'd rather say the discounts for committed use discount commitments. If you look at the 3 year commitment, if you look at the 1 year commitment, you get the discount for 1 year commitment without any commitment. That's what you get from us. So no matter the regional machine type specific discount, and they might vary quite a bit, always look at the 1 year discount, and that's exactly what you get with our FlexSave offering.
And I think this is a game changer because a lot of customers that join DoiT, they want to rationalize and stabilize their architecture, and then maybe think about having a discussion about making a 1 or 3 year commitment. But what this enables them to do is to join DoiT today and start to benefit from some of those discounts without having to change their architecture at all. Often, to make commitments, what you want to do is to want to make sure that your architecture is such that you're kind of got a stable usage throughout the day, the week, the month, that justifies paying for that machine on a committed basis. But it's really just a no-brainer to leverage this now. So yeah, I'm super excited to talk with more customers about this.
I've seen an interesting chart where it shows like you can still have your committed discount. What FlexSave does is just automatically figure out the delta between your peaking workloads and the stuff that's steady, and automatically apply this discount to those, basically filling up the gaps from your otherwise possibly existing CUD. So that's really cool. And there's really no downside to it. You can just enable it and start saving. That's really awesome, I think.
So, like, if committed, if you've already got some commitments on that's your bread and butter. This is almost like the jam on top to kind of fill in all those gaps and make everything lovely. Wonderful. Wow, we've covered a lot of stuff. I feel like I feel like if you watch this 1 hour video or so, you're gonna have Cloud Next wrapped up in like a three days of many virtual talks wrapped up in a short time. So I hope that's been really useful for everyone. And thanks both. I feel like I've learned a few things there, a few things that I missed watching the videos last week. So that's been really great.
Awesome. Yeah, it was nice doing this with you.
So I think we'll share the links to the Cloud Next session, so you can go and explore, do a bit of a wiki walk and find the services that are most relevant to you. Thanks to DoiT for sort of hosting this talk, and please do reach out to us if you're looking to get the most out of Google Cloud. Then please reach out to us, and we'll be happy to talk about how we can help you with that. And I guess for now, that's we'll wait until 2022 and maybe do another one of these in a year's time.
Sounds amazing. Let's do that.
Fantastic. See you guys.
Bye, everyone.
Goodbye.
Have a good one.